Good morning, all. I am Uma RM from Srimati Kumar Institute of Technology. Today, we are going to see in basic electrical and electronics engineering uh, representation of sinusoidal waveforms. A voltage which changes its polarity at regular intervals of time is called an alternating current. When an alternating voltage is applied in a circuit, the current flow first in one direction, then in the opposite direction. The direction of the current at any instant depends upon the polarity of the voltage that is shown in this figures. The instantaneous value of alternating voltage is given by V max sine omega t, where omega is the angular velocity of the coil. Uh, the value of alternating voltage and current. In a DC system, the voltage and the current are constant so that there is no problem in specifying their magnitudes. However, an alternating voltage or a current varies from instant to instant. Naturally, the question arises how to express the magnitude of an alternating voltage or current. There are three ways of expressing it, namely peak value, average value, or mean value, and RMS value or effective value. A peak value. It is a maximum value attained by an alternating quantity. The peak or maximum value of an alternating voltage or current is represented by V max or I max. The knowledge of peak value is important in the case of testing materials. However, the peak value is not used to specify the magnitude of alternating voltage or a current. Instead, we generally use RMS value to specify alternating voltage or current. Then average value. The average value of a waveform is the average of all of its value over a period of time. The next one is RMS or effective value. The RMS or effective value of alternating current is that steady current which, when flowing through a given resistance for a given time, produces the same amount of heat as produced by alternating current which flowing through the same resistance for a same time. Next, the phase difference. When two alternating quantities of the same frequency have different 0 points, they are said to have a phase difference. When alternating current is applied to a circuit, an alternating current of the same frequency flowing through the circuit. In most practical circuits, for reasons we will discuss later, the voltage and current have different phases. In other words, they do not pass through a particular point, say 0 point, in the same direction at the same instant. Thus, the voltage may be passing through its 0 point while the current has passed or it is yet to pass through its 0 point in the same direction. As so we say that the voltage and current have a same difference that we can see clearly in this figure. Phasor representation of alternating voltage. Alternating voltage have varying with magnitude and direction, so they are represented by a rotating factor. A phasor is a vector rotating at a constant angular velocity. So here we can see that angular difference of it. So these are the reference book that we refer to have about the introduction of alternating or instantaneous um, current and voltage. Thank you. Thank you all. Have a wonderful day.